Hi, welcome to the video solution guide to problem number 7 from the second problem set. This problem is asking for the stretch or the change in length of a tendon due to a 1200 Newton applied force. And we're told that the starting length of the tendon is equal to 4 centimeters, so I'm just writing down the known parameters of the problem. We're also told to use the same tendon from the previous problem, problem number 6, where we found that the radius is equal to 1.8 millimeters. That's the radius of the tendon. And we're also given the modulus of elasticity, which is equal to 1.5 times 10 to the 9 newtons per meter squared. Let's go ahead and make sure that our units are consistent. We see we have 4 centimeters up here. Let's write these in units of meters, so it's 0.04 meters. And then the radius of the tendon will be 0.0018 meters. So now all of our units are consistent. We have meters, meters, and meters squared. The tricky part of this problem is to figure out which equation to use. If we look in our notes, we see that the equation, the force applied to a tendon equal to the tendon stiffness times its change in length. This might be a good equation to start with because we know the applied force, we know F. We're looking for the change in length, and it's possible that we might be able to solve for this K here. So the tendon stiffness, K, is equal to the modulus of elasticity times the area divided by the length of the tendon. We're given the modulus of elasticity, we're given the length, and we can solve the area as the radius squared times pi r squared. So now we have all of the constituents of this tendon stiffness are known. Let's go ahead and write out the full equation. We'll call this equation 1. We'll expand equation 1 with our variables from K. So we have the force is equal to the modulus of elasticity times the area of the tendon divided by its length, so that's K, times its change in length. This is what we want to solve for. We want to solve for the change in length. So we'll reorganize this equation so that the change in length is equal to the force applied to the tendon times its length divided by modulus of elasticity times A, and we're just getting this by multiplying L over there and dividing by E over A down there. So that's how we're getting this new equation here. I'll box that. So now our unknown is on the left, change in length, and we know the force applied to the tendon, we know the length of the tendon, we know the modulus of elasticity, and now we know the area. So now we can go ahead and put in our known values. The change in length is going to equal 1200 newtons times the starting length is 0.04 meters. And I think it's important to include the units, that way we can do a unit check at the end. We'll make sure that the units cancel appropriately. Now the modulus of elasticity is 1.5 times 10 to the 9 newtons per meter squared. And the area is going to equal pi times the radius, 0.0018 meters squared. So now we're going to have a meter squared cancel here and here, and Newton and Newton cancel there. And what we're left with are an answer in the units of length, so it'll be given, the change of length will be given in meters. When we crunch these numbers, we find that the change in length is equal to 0.00314 meters, but we're asked to answer this problem in units of millimeters. So if we multiply it by 1,000, we'll get 3.14 millimeters, and that's our answer.